So if I know it has to be greater than or equal to 0, how do I solve that for x? Subtract 1 and I get x is greater than or equal to. Okay, why does that work in terms of the graph? What does that plus 1 do to the graph? Shifts it which way? Left 1. So instead of my vertex point, in quotes, being at 0, 0, where is that vertex point now? At negative 1. Look at question 5. For question 5, it's underneath the radical, underneath the square root symbol, was negative 7 times x minus 7 is greater than or equal to 0. So again, same principle. We start off with what's underneath the square root symbol. We write that it has to be greater than or equal to 0, and we solve for x. How do we do that? Distribute. Okay, what else could I do instead of distributing? Divide. Either one's going to work. I'm eventually going to do both. I'm eventually going to divide if I distribute first, or I could divide at the beginning. I'm going to divide at the beginning. What do I divide by? Negative 7. Why? That's the coefficient. Now I want to get rid of it. And remember, we learned we can do whatever we want to one side of the equation. Exact same thing has to be done to the other side. So if I divide negative 7 by negative 7, they cancel. I'm left with x minus 7. What is 0 divided by negative 7? And then what happens here? Why does it flip? Yes. Okay, and then what does your minus 7 do? What do you do now to get rid of that minus 7? And I get that x is less than or equal to 7. Okay, talk to me about graphically why that happens. What does this negative sign here do to the graph? It reflects it over the y-axis. So that means instead of the graph opening out to the right, which way is our graph going to open? To the left. So how did that affect our equation? What did that, when we started solving for our domain, how is that negative, that reflection, how is that shown in here? How is this reflection shown in our work here?
When you divide by the negative 7.
When you flip the sign. When you flip that sign, when you divided by the negative 7, it reflected it. Okay, let's talk about our range for a second. So on your reference page, it gave you very specific information about your range. It told you how to find it without you having to do a whole lot of work. So it said it all depended on A. If A was greater than 0, what kind of numbers are greater than 0? Or if A was less than 0, and what kind of numbers are less than 0? Negative numbers. Then that determined what happened with our range. If it was y is greater than or equal to D, or y is less than or equal to D. Where does it mean when it's talking about D here? What is that referring to? Yeah, which translation is that? Yes. So in problem 3, let's look at 3. D is negative 3, so I know it has, my range has something to do with y and negative 3. It all depends on if A is positive or negative. So what's A in our problem? It is negative. What does that negative do to the graph? Reflects it where? Over the x-axis. So instead of it shooting up towards positive infinity, that means our graph is going to shoot down towards negative infinity. So it's going to be y's that are less than or equal to negative 3. Okay, what about on problem 5? What's the number in front of the, what's A in this problem? 1. Is that positive or negative? Positive. There was no reflection, so my range is going to be y's that are greater than or equal to what? What's here? 0. All right, we're going to start with page 571. I'm going to do a little bit on 571. We're going to write some random stuff on 572, and we won't get through a ton today, but I have to lay the foundation today for what we're doing tomorrow. So we're starting with where it says here, the function f of x. So let's start with f of x. What is that? Okay, that's important. It just means y. It's a different way of writing it. It literally means, if I were to put f of x into words, it means the function f evaluated at x. Like, that's actually what it means. But f of x is way shorter, and we're lazy people, so let's just go with that. Let's talk about the word function, because we have to understand what a function is. And it's been a long time since you talked about them, and Algebra 1 would be the last time you heard about a function, most likely. So does anybody remember what it means to be a function? Okay, a function is a graph where the x's don't repeat. So as long as all of your x's are different, it's a function. The moment that your x's start to be the same, something's not a function. And that's incredibly important for you to understand in what we're starting with today. When you look at an actual graph, like if you don't have points, you can do what's called the vertical line test, or the VLT. We're going to talk about that a lot over the next couple days. Not a BLT, not a bacon, lettuce, tomato sandwich, a VLT, the vertical line test. The vertical line test says if I can draw a straight line and it touches the graph once, it's a function. If I can draw a straight line and it touches the graph twice, it's not a function. So which of these two, let me draw it in a different color so we can specify better. Which of these two is not a function? The black one, because if I draw a vertical line, said vertical line touches the graph once, twice. Okay. I have these ordered pairs here. And first of all, it did tell me they were a function. We're going to verify they're a function. So what makes them functional, it says, is that all of our x's should be different. So I'm going to highlight the x's just so we can refer to them. -2, -1, 0, 1, 2. Are in fact all of those different? So that means it is in fact a function. Okay, so the next part of this is, what if I asked you to find the inverse of said function? What does the word inverse mean? To flip, the opposite, something like that. So what if I said find the inverse, what might you do? Make them negative? Flip the signs. What? Why not? Okay, so if I'm going to invert something, what could that potentially mean? I'm sorry, we were talking about this and I got distracted by the phone call. What could that potentially mean? Maybe switch the signs, that's a possibility. So maybe you're flexing over the y-axis. Mathematically, if I flip something over the y-axis, what's changing about it? The x's are changing. Okay, that's a possibility. What else? Flip the ordered pair, what do you mean? When I want to find an inverse, all it means is I'm switching my x's and my y's. So instead of -2, 4, my ordered pair would be 4, -2. Instead of -1, 2, what would it be? 2, -1. I'm just switching x and y. Okay, would 0, 0 change? Nope. Okay, what would be the next one?
2, 1.
Okay. And okay. Out of curiosity, and this is not something we're necessarily going to talk about today, but I need to identify this just to kind of, again, lay the foundation work for what we're doing tomorrow. Is this set of ordered pairs also a function?
No.
Why not?
Because
Okay, so there's 2 4s and 2 2s. So I'm going to write that on the next line. No, it's not. 4 and 2 repeat. You are writing now, because this is important, that inverses are reflected across y equals x. Inverses are reflected across y equals x. I wrote mine on the first page of 11, just like on 11.1 at the very beginning. But you need to underline that, circle it, highlight it, star it, bubble it, like bold it, whatever it is, because you have to understand that they are reflected. Yes, they are reflected across y equals x. We're not going to write anything that's in the book, so you have that whole space to write what I'm telling you to write. So I want you to write the equation y equals x plus 4. And again, you can write this on the back of page 571, on page 572. We're not going to write anything else on this page, so that space is perfect for this. If I said, hey, find the inverse of this function. What we just did with the ordered pairs, what did we do with the ordered pairs? We flipped what?
X and Y.
X and Y. So if I want to find the inverse of this function, what do you think we're going to do? We're going to switch X and Y. So instead of y equals X plus 4, I'm going to write X equals Y plus 4. I found the inverse. Now, the only problem with that is we can't actually graph anything if it says X equals. What does it need to say in order for us to actually graph it? Y equals. So how do I solve this for Y? Subtract 4 from both sides and I get X minus 4 equals Y. That is my inverse. Now, I'm going to write it in what we call inverse notation. Inverse notation says F inverse of X. When you put this -1 here, I realize like that's an exponent. Not disagreeing with you because it's in the place that an exponent is. But in this case, it's not an exponent. It's a superscript. Y'all know what subscripts are? They're at the bottom of numbers. Superscripts are at the top. When you have things in function notation and you put numbers in there, and this is something you'll do in calculus a whole lot. But with Algebra 1 and with Algebra 2 and Pre-Cal, the only thing we really do with this is inverses. Y'all saw this in physics when you were doing cosine -1. The inverse of cosine, the inverse sine. It's the same idea. When we write this f -1, we're not saying f to the negative first power. We're saying this is the inverse of f of x. Okay? So f of inverse of x equals x minus 4. That would be my equation. All right, your next one. Y equals 3x minus 12. Y equals 3x minus 12. So I want you to find the inverse of that. What do you need to do first?
You need to switch the X and reconnect your iPad.
Okay, so to find the inverse, we're going to add 12 to both sides because I'm trying to get, oops, sorry. We need to actually flip x and y first. So x equals 3y minus 12. Then we can add 12 to both sides. So x plus 12 equals 3y. To get y completely alone, we're going to divide by 3. We divide everything by 3. Remember that there is a 1 in front of this x here. So I end up with 1/3 x plus 4 equals y. But really, instead of y, we're actually going to write f inverse of x because that is going to be our correct notation. So that would be my inverse. So our next problem is y equals... You're welcome. 1/2 x plus 5. So if I'm going to find the inverse, what do I need to do first?
Minus 5.
I need to rewrite it so that I'm going to flip my x's and y's so I get x equals 1/2 y plus 5. That's the very first thing because we can't resolve this until we've got y in there. Okay, so then if I'm ready to resolve, what do I do now? Subtract 5 from both sides. So I'm going to minus 5, and I get x minus 5 equals 1/2 y. Mathematically, what do I do to get rid of that 1/2? Multiply by 2. You could divide by 1/2. That's fine. But we can also multiply by 2, which makes things a little bit easier because it just tells us what math we do. And when we do that, we multiply both sides by 2. We get 2x minus 10 equals, instead of y, I'm going to write my inverse, which is f inverse of x.